Hi everyone, in this video I'm just going to go over some of the key points from Unit 1.7. One of the most important things that you're using in this unit is the order of operations. So just to kind of take a moment and review those operations with you. A lot of you remember PEMDAS as the order of operations, but it's a little more than just those letters. So I want you to remember that the P stands for any grouping symbol, and you're to simplify within the grouping symbols first. So grouping symbols could just be parentheses. They could be the square parentheses or brackets, braces, or those like curly looking parentheses. They could also be fraction bars. So you could have a fraction where there's more than one operation in the numerator and or denominator, and you could simplify the top and bottom first before you look at the fraction. But we also could have radical signs like square roots or absolute value bars. And if there are any operations inside of a radical sign or inside of an absolute value bar, you go through the order of operations within those first before you take the root or before you take absolute value. So the second step, which we usually think of as E for exponents, does mean to simplify exponential expressions, but it also could mean to take roots like square roots or to take the absolute value. M and D stand for multiply and divide. Those go in order from left to right. There are some times where we can get around that order. Multiplication can be done in any order because it has that property that is commutative and also associative. Division can sometimes be turned into multiplication. So, if you turn your division into multiplication, you may be able to play around with the order. But that goes into some of the properties of expressions as well. If you follow, going from left to right for multiply and divide, you cannot go wrong. Same thing for addition and subtraction, which is the last set of operations that you work on. If you have addition and subtraction, you work those from left to right as well. We do see sometimes that subtraction can be turned into addition of a negative number. And if you do that, then of course you can change the order around because addition is also commutative and associative. So there are some ways that we can get around order of operations, but if you always follow these procedures, then you'll simplify an expression in the way that it was intended to be simplified. So what you should take away from this unit is not the tax form itself, but being able to write expressions given some words, or being able to take multiple expressions and put them together as one single expression. I just want to remind you that an algebraic expression is just a mathematical phrase with numbers, variables, and operations. An expression itself does not have an equal sign, does not have an answer to it. So in question 3 in the unit, you were asked to refer back to the calculations for Marianne Lopez. Remember, you had to find her net profit by subtracting. That's shown here. You then had to take that net profit and multiply by 92.35%. That gave you her taxable income. So that reduced her income to 92% of it. So that would be the amount that she is taxed on. And then you took that taxable income and multiplied that by the rate of tax, which was 15.3% or 0.153. And now, right now, I don't want you to focus on the meaning of these calculations. I want you to focus on how to take these 3 calculations and put them together into one expression. Now, since the subtraction was the first thing that we had to do, we're going to need parentheses because in general, subtraction is one of the last operations that we do, right? If we go back up here, subtraction is the very last thing that is done. But in our particular situation, it makes sense that the subtraction is done first. So we can write the subtraction 11,385 minus 3,862, but notice there are parentheses around that subtraction because that means that has to be done before any of the multiplication is done. The remaining 2 steps are multiplication steps. So here I use parentheses to show multiplication. So if there's no symbol between a number and an open parenthesis, that means multiplication is happening in between. There are other ways you could show multiplication. You could use the dot, or if we were typing, we could maybe use like the asterisk symbol, but we try to stay away from the X multiplication symbol, especially when we're writing expressions, because we don't want it to be misinterpreted as a variable, and we will be using variables later on. So here I represented the multiplication in parentheses as well down below. So after subtracting, I then multiplied by the decimal 0.9235 and then multiplied by the other decimal 0.153. Now this is just one example of how the expression can be written. You can play around a little bit with the order of the multiplication. So some of you might have both of your multiplications before the subtraction. You could have either one of these before as the first one, and that doesn't matter, because when a person sees this, if the subtraction is in parentheses, that's the first thing that would be done before any of the multiplication. And again, since multiplication is commutative, you could change the order of it and you'll still get the same result. Notice that none of the answers that you get in between, these intermediate answers, are shown in this expression. It's just what are the operations that are being done. All right, so one of the next things that you had to do in this unit was to read a table, and from that table interpret the calculations and then actually calculate the tax that is owed. So you saw an example with language like this. You had a whole table, but I'm just kind of pinpointing one row of that table. Now the numbers here are completely different than the numbers that were in the unit. I just want to give you another example. So let's say that the tax owed for income between $50,000 and $64,999 is $4,120 plus 25% of excess income over $35,000. Calculate the tax owed for an individual making $56,000. So we see very similar language to what you saw in the unit. So we want to make this expression 4,120 plus 25% of excess income over 35,000. We want to write that in an expression form, and you see that down below. So first we have the 4,120 plus 25% is written as a decimal, 0.25. Whenever you're taking the percent of something, you are writing that operation as multiplication, so 0.25 times. Now, the of is actually a subtraction. This excess income over 35,000 means to take the income that that individual takes in and take 35,000 away from it. So that's what you see in the parentheses here. This would give you the excess over 35,000 for this individual making $56,000. So now I'm showing you the steps in terms of the order of operations. If we were to do this step by step, the first thing that would be done is the subtraction. Then you would multiply that $21,000 by 0.25 to get the 25%. That gives you $5,250, and then you would add that to the $4,120 to get $9,370. Again, that's not the only way you could have simplified this expression. You could have, if you wanted to, distribute this 0.25 and multiply that by both of the subtraction, both of the values in the subtraction, and then went ahead and did the subtraction after. So that's one way that you can get around the order of operations. But in this case, we probably wouldn't do that. We would probably go ahead and subtract first. It seems to be a simpler approach. Do notice that there is no reason would we add these two values together first before we multiply. If we had done that, we would get a completely different answer, and that would completely just not follow the order of operations. All right, so two important things that you should take away from this unit. First is that quantitative reasoning requires skills in reading, interpreting, and using information. So you should be able to read through text, written word, translate that to mathematical expression, but also interpret the meaning, like understand that if we're trying to find excess over something, that should be written as a subtraction. When it's a percentage of something, that is interpreted as a multiplication. You do need to have some understanding of and meaning of calculations like I just mentioned, order of operations, and flexibility of methods. So understanding, again, the order of operations is crucial, but knowing that we can change some things around, like addition, we could change the order, multiplication, we can change the order. That gives us some flexibility in how we calculate and how we write our expression.